Okay, guys, so this lecture is going to be just a little bit different because it's hard to show you on my computer screen how to use maps. So my friend Tyler is helping me record this, and this is an actual paper copy of the map that you're going to use. So first, let's talk about the things that you're going to need in order to complete this lab. You're going to have to download the lab sheet that has the answer sheet on it. It also links you to a whole bunch of extra reading that would be very helpful if I haven't explained this well enough for you. And you're also going to need to download the Dardanelle map. It's in a .pdf format. You'll be able to zoom in and zoom out, and I will make another video showing you how to do that on your computer screen. So let's go ahead and get started with the parts of a map. This is a topographic map. Topographic maps show the change in elevation on the Earth's surface. So it takes a three-dimensional object and represents it in 2 dimensions. So as we look at our map, there's important things that you always need to note. There is the title of the map. This is the Dardanelle Quadrangle. You will notice underneath it, it says that it is a 7.5 minute series map, saying that it is 7.5 degrees wide and 7.5 degrees in height. If you go to the bottom, you'll find when it was published. This is not the same publishing date as yours. Yours is newer. And then we also have our scales, and it has a little bit of some other things. We got a little legend. These maps are not really known for printing complete legends. So if you have questions, just Google anything you see on here and it'll pop right up, no problem. So in order to start using maps, we need to make sure that we understand the basic concepts, like the difference between longitude and latitude. So you will see on the map, if you look over here on the left side, you will see lots of numbers, starting with this one right here. This says 35 degrees, 7 minutes and 30 seconds. That is a line of latitude. Latitude lines are the ones that run horizontally. If you go to the top of your page, you will see up here it says 93 degrees, 7 minutes and 30 seconds. These are your lines of longitude. Longitude runs vertically, okay? So you're going to have some questions in the lab about, what the borders of the map are. Make sure that for the longitude lines, you use the upper numbers up here that start with 93. And then the latitude lines start with 35 at the top and the bottom. They'll be different. Okay, so after we've established our latitude and longitude, there is something called a grid system. And the grid system is separated into townships and ranges. So in order to find townships and ranges, once again, we're going to go to the outside border of the map, and it's usually in red. So you will see here T7N and T6N. This is our township. So when we look at this map, everything that is above this red line is going to be our Township 7 North. Everything below that line is the Township 6 North. Now, don't let it throw you off that they both say north, because we are looking at a map that is in the northern hemisphere. Now, that's township. Ranges are going to be along the top of your map. You will see that it says R21W and R20W. Everything on the left side of this line is going to be R21W, which stands for west, because we're in the western hemisphere. And then range 20W on the right side of that line is going to be that range right there. And also within every single range and township, you're going to find 36 squares called sections. So if you look closely, you'll see these little red numbers. This is the section number. Just to give you an example, if I have let's just call this T1 North and range 1 West. I can separate this into, I'm going to do it unevenly, 5, 6, 1, 2. So you see it could be 1, 2, 3, 4, 5, 6, 7, 8. Every single one has up to 36 sections. And then within each section, we can separate it into quarters. So what I'm going to do, I'm not writing on the map, I've got a little piece of plastic. I'm going to outline this, section 36. And then I can separate it into quarters. And we label those quarters as northwest, northeast, southwest, and southeast. But that's still a large plot of land. So we can quarter the quarters, just like a window pane. And we do it just the same way. We would call it northwest, northeast, southwest, and southeast. So let's actually do something with this. So what I would like to do is let's take a look at these gravel pits right here. I want to show you how to label this. And the funny thing about using the grid system is it's backward. So you would write it as quarter, T, quarter, section, T, and R. Okay, so we're going to write that down here in just a minute. So first we need to figure out, since it's backward, the township and range. So we're going to look over here. Here's our little gravel pits. You'll see that it's in Township 6 North. So let's get our little thing over here. And we're going to write Township 6 North. Let's figure out the range. Here's our gravel pits. We're in range R21 West, because we're on the left side. 21 West. And if you look, you can see right there it says 2. So we're in section 2. We're almost done. Now to figure out what part of the section it's in, let's outline our section. And we're going to quarter it. Notice the gravel pits are in the northwest corner. So on our sheet of paper over here, the first one is going to be the northwest quarter. And we're going to do it again. And you'll see again we're in the northwest quarter. So when you say this out loud, if I said, please meet me at the gravel pits, I would tell you that it's in the northwest quarter of section 2, Township 6 North, range 21 West. If you are having trouble finding things this way, there are lots of online resources that you can use to try and figure out the grid system. Just don't forget, you always start here. I know that that isn't what we would normally do because we read left to right, but in this system, we have to work from right to left. Okay, so we've got the grid system started. Let's talk about map scales. So this map has two kinds of scales. This is a fractional scale. So when I ask you on the lab, what's the scale of this map? This is what you're going to write down right here, 1 to 24,000, okay? I just gave you an answer for free. Now, this is what we call a bar scale, and this is the one that you're actually going to use on the lab. And I'm going to show you here in just a second how to use the bar scale, and I'm going to make another video to show you how to use the bar scale on your computer. So let's go ahead and move on, because we are talking about maps, but we haven't talked about elevation changes at all. So how do we see elevation changes? If you look at the map, you will see a whole bunch of brown squiggly lines. These are called contour lines. Each line represents a very specific elevation in relationship to sea level. So you will see this one right here at Hobson's Knob. See how it says 450? That is 450 feet above sea level. If I were a little person and I were walking all along that dark line, I would be walking exactly at 450 feet above sea level. Now you'll notice that there are some lines that are darker and some that are lighter. The darker ones are index contour lines. We can't write a number at every single line because then the map would become jumbled and impossible to read. So we have these that we label like every 5. So if you come down here to the bottom, you'll notice something called contour interval, and it tells you that it's 10 feet. So there is a elevation change of 10 feet in between every single one of these lines. So this is Hobson's Knob. It's a hill. So if I'm standing right here at this 450-foot contour line, and I move up to the next one, which is lighter in color, and it doesn't have a number, but I would know that I'm going uphill, so that would change it to 460. So we go 460, 470, 480, 490, and then the next index line, the dark one, should be 500 feet above sea level. So there are some rules when we talk about contour lines. First is they don't ever end. You will see that they might make a closed circle, or they might run off the side of the map, but they never just stop. That's because elevation changes. It doesn't just stop into oblivion. Even at a cliff, there is a definite elevation, even if it's a very severe change. When we look at a map, I can tell you without counting and doing any calculations where the flat spots are and where are all the steep spots. This right here, this entire white part, is pretty flat. I know this because the contour lines are super far apart. I know that over here is very steep, not because I see that that says mountain, because you see a whole bunch of index lines and contour lines are all very, very close together. This indicates steepness. So very steep area, very flat area. Also, when we look at hills, let's go back over here to Hobson's Knob. You will see that they are closed. It's not really a circle, but any closed contour line is going to indicate a hill. Now there's something opposite of a hill that's called a depression, which is like a sinkhole. And those look like hills, but they have little hatch marks that indicate that the elevation is actually going down. So like if this is 20 feet right here, this one is 10 feet. So that means a depression or a sinkhole. Also, when we look at contour lines, we need to think about how that is represented when we talk about stream channels, which are anything from rivers to creeks and rills. So let's go on all the way up here to, you'll see right here it says Hayes Creek. This is Hayes Creek. If we look at it, you can see this little contour index line. It comes to a point and then comes back up. if we look at every single one of them, they all come to a point over the creek. I'm going to draw you a very simplistic little picture. So let's just say that we have ourselves a nice little creek right here. Now, water runs downhill. It never goes uphill. Water is subject to gravity, just like you and I. So if this is the direction of water, and that's downhill, the contour lines are going to come up and they're going to point uphill. Do not get this confused. My students every single semester think that the contour lines point in the direction of the water. It does not. It points to the direction of uphill, up slope. It is steeper here. It is higher in elevation here than it is here. 30, 20, 10, okay? And that should make sense that water is going to flow from the highest spot to the lowest spot. All right. Now those are our rules about contour lines. I want to point out really quick some of the important places that you're going to have to look for on the map when you're doing your lab. It can be very frustrating to find some things. Now, some things I've given you the township range section and stuff for you to find it. Others, it just kind of describes to you where they are. So I'm going to go ahead and show you. So starting at the top, there's several questions over here. Like here's the Arkansas River right here. There's the radio tower, so it can help you find it. If you go directly north, there's a power plant that you need to look for in one of the questions. Let's see. Also, there is, if you go south of the radio tower, way far south, and then over here toward the center in section 14, there's a church called New Hope Church. And then directly above it, there's a creek called Polpen Creek. You'll be using that one in a question. If we go northwest from there, you have a question about Jones Mountain. And I want to point this out to you. Right here, do you see these little double dashed lines? That indicates a road. The question asks you about the end of the road. The end of the road is right here where I'm pointing with my pencil. Okay? It's going to ask you about elevation. And also, let's see, where else did we have a question? I thought and one of the questions is going to ask you about contamination movement and whether it'll go into Smiley Bayou. This is Smiley Bayou, this whole thing over here, but here's the words. And also, you're going to be doing a part on stream gradient, and this is where it is. It's going to ask you to do from 350, so you have to actually find where the contour line crosses over on Harris Creek. And let me warn you, it is very, 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 very incredibly long. Where is the end? I've lost the end. Did I go the wrong way? Creek, 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 creek. There. It's all the way over here. So you're going to have to measure a lot of stuff. So there's those things that you need to find. I'd like to show you some calculations really quick. There is something called relief. Relief is just the maximum elevation minus the minimum elevation. So I want to take a look at Hobson's Knob and Thompson Cemetery. So if we go down here, there's Hobson's Knob and there's Thompson Cemetery. So we are going to see, since the knob is a hill, it's likely to assume that this is going to be our highest elevation. So we are going to go and count it. So we know that that's 450. The next index line is going to be 500. Let me do a little magic here. And yep, there's one more little contour line inside. So that's going to be 510. So our max elevation is 510 feet. Now, we're going to go look all the way over. We're going downhill. See, there's 350. And we're going downhill some more. And we're going to call Thompson Cemetery right here at, let's see, 360. So if this is 350 and we're going uphill this way, this one's 360. So minus 360. So the relief between the hill and the church, or the cemetery, is going to be 510 minus 360, which equals 150 feet. That's just relief. Now, when we talk about gradient, we need to determine the relief and divide it by distance. This is going to be slope or steepness. Okay? So we already know the relief. We calculated it up here. So let's go ahead and write in our 150 feet. Now, when we talk about gradient, we usually like to study it in feet per mile. So we are going to measure on our map the distance between the top of the hill and that cemetery. I'm going to use a ruler for this one. So from the middle of the hill to the middle of the cross in the church, it looks like we are 5.8 centimeters. So we're going to take this down to our scale bar, okay? We don't want to do kilometers and we don't want to do feet. We're going to do the mile. First, let's see. Now I want to show you this. This is tough, and it's what people always have a hard time with. Right here, this is 0. You do not use the whole scale bar at once. You always start from 0. So as you can see, 5.8 doesn't quite make 1 mile, so it's less than a mile. So we cannot use this side. We're going to go over to this side. And so I'm going to match up my 5.8 mark right here at the 0. Okay, do you see how I've done that? There's 6, 9, 8. Oops, I'm over one too far. Now, I need to measure right here at the very end. Okay? This shows you that's half a mile. That's 6/10 of a mile, 7/10 of a mile, 8/10. We're not quite to 9/10. So we're probably about 0.85 miles. So that's what we're going to put down right here. 0.85 miles. So we're going to get out our trusty little calculator. You like my pink calculator? So we're going to take 150 and we're going to divide it by 0.85. And it gives us 176.5, we'll just round it to the nearest tenth, feet per mile. That's pretty steep, y'all. That's a real hike. So that's how we calculate gradient. Now there's something called stream gradient. And this one is a little more difficult because you can't measure the distance in a straight line. You have to follow the path of the stream. So what we are going to do now is we're going to calculate stream gradient on Hayes Creek up here in the top part. So I'm going to actually put my stuff on so we can see very clearly. So on my notes, I said let's do it between 500 and 550. So I'm going to draw in the creek that we are going to follow. Let me find the correct part. Okay, here we go. So here is part of the creek. I'm drawing it in blue. Okay. Now, you can see which way the little V's are pointing. They're pointing to the northwest. So the northwest is uphill. So the water's actually flowing in this direction, okay? So I'm going to get another color And I'm going to draw in right here where my contour line, and this one's the 500. This one right here is the 550. Okay? So, if it's just relief divided by distance, the relief is the maximum minus the minimum. So the difference is 50 feet. Okay? 50 feet. Now we got to determine the distance. I'm going to move this off of here real quick just so we can get a more accurate depiction. This is where you may have to use a string. Now, this stream channel, since it's so steep and uphill on a mountain, it's pretty straight. The one that you're going to measure is not straight. So what you need to do is you need to take your string and try and make it match the shape of the stream channel. If the stream curves like this, make it curve like that, okay? You have to make it match the stream channel the best that you can. And if you have a string that you can write on, that's even cooler. Okay, so I'm gonna make a blue mark there, and I'm gonna try and match this up. Of course, I cheated, I picked a straight stream, didn't I? Okay, so now we need to find the distance between these 2 points on my string. I'm gonna take it down here, back to the scale bar, and I'm going to take it to the 0. Obviously, it's not going to be a complete mile, right? So let's put it over here on the fractional side. So match it up with a 0, 1/10, 2/10, 3/10. We're right in the middle, so that's going to be 0.35. So let's get our little thing back out. Wrong color. 0.35 miles. And then we can calculate it. 50 divided by 0.35. All right, so the answer is 1,429 feet per mile. Okay. If you have any questions on the lab, please send me a Blackboard message and be sure to do some reading. Try and Google it. Try and figure it out on your own first. Be prepared to take, photos or screenshots of your lab as needed so we can figure this out. All right, guys. Thanks.